Leetcode number 9, palindrome number. And in this question, it says, given an integer x, return true if x is a palindrome and false otherwise. If you are not sure what a palindrome is a word that reads the same from the left to the right as it does when from the right to the left. So for instance, my name, Ada, is a palindrome because when you read it from the left to the right, it's ADA. From the right to the left is ADA as well. So that's a palindrome. But something like book is not a palindrome because when you read it from the left to the right is book, but from the right to the left is cube. And well, that's not the same. The first time I solved this problem, I basically converted the number to a string. So you have 121. Actually, there are a lot of ways that you can solve this problem. You can reverse it. So for instance, let's say we had 121, and let's assume that 121 is a string, right? Now, if we have 121 as a string and we reverse it, it's still going to give us 121. But the problem with this solution is that it's not as efficient as maybe having 2 pointers. So let's say we had a pointer at point 1 and we had another pointer at the second one, and you see that when we check, okay, is 1 equal to this one, it's the same. And when we move the pointers to 2 and it checks, and at this point it's in the middle, so we know that it's a palindrome and it works out fine. The time complexity for this one is going to shorten the time complexity of doing the whole reverse thing by 2, right? So it's much faster. All right, and when I solved this problem the first time, I did this. I converted the number to a string, and then after converting to a string, I now checked for, like, I checked the if the adjacent ones are the same, and if they were the same, I said it was a palindrome, and then just return true or false as the case may be, right? So, but follow-up question says that we should check if you can solve it without converting the integer to a string. So we should try not to, don't convert, basically perform the operation as if you're working with a number, because, well, you're working with a number, right? And that's what makes it harder than converting to a string, because you can't perform those string operations on this one, right? So I had a little help, but I figured out how to actually get the values of the leftmost number and the rightmost number to be able to compare it. So we're going to be using the similar idea from the string, getting the leftmost and the rightmost and checking it, and then moving the pointer inward until we get to a point where there's nowhere else to move, or we just have one number in the middle, and we know that, okay, yeah, this is a palindrome, something like that. We'll be running on the same principle. So if you want to get the rightmost element in a number, apparently doing doing whatever the number is, getting whatever the number is, and modules 10 of that number is going to give you the rightmost number. So when we do 121 in this case, since that's our example, modules 10, it's going to give us 1. And then when we want to get the leftmost element, I'm actually going to do this in a way that it makes a lot more sense. So when we have 4,000, for instance, 4,000 is an easy number to divide. 4,000 divided by, since 4,000 is in the thousands, you have to divide it by 1,000, right? 4,000 divided by 1,000 is going to give us 4, right? So in the same vein, 121 divided by 100 in this case, because it's in the hundreds, is going to give us, when you round down the value, it's going to give us 1. And in this case, we can be able to compare, okay, 1 is equal to 1, so it's the same, and then we move our pointer to 2. When we perform a similar operation on these 2, you see that it's actually going to give us 2 as well. So the problem starts when you say, okay, yeah, I performed this operation and I know that 1 and 1 is the same, but how do I get the value of 2 now instead of like having 1 to 1? Because when you perform this operation, you want to get rid of the first one and the last one, and you just want to have 2, right? So to do that, what we're going to do is that we're just going to get the number 121 in this case, and we're going to take the modules of the divisor, which in this case is 1,000, in this case is 100. So right, and then we're going to divide it by 10, and then whatever we get here, if we do this, you see that the answer is going to be 2. Now this is the new value of x, right? And then for our divisor, because we got rid of two values, so every time we go through our divisor we get rid of two values. So we're going to reduce the value of our divisor, in this case, which is 100. We're going to divide it by 100, so we get 1. I hope this makes sense. But when we start coding it up, you actually get to see it will make more sense when you start coding it up. So for instance, we have my -121 here. Now -121 121 on its own is a palindrome, but -121 is not a palindrome, because from the left to the right it's -121, but from the right to the left it's 121 minus, so it's not a palindrome. And then 10 is not a palindrome because 1 and 0 is 10, but 0 and 1 is 1. Get? Great. So actually this negative number gives us an idea for our first line of code, which is just going to be us checking if x is less than 0, because if x is less than 0, we're just not going to bother with any other thing. We'll just return false, because why not? Then the next line of business is for us to find the divisor, because just imagine if we have, so if we have 121, our divisor is 100. When we have 4,000, our divisor is 1,000. When we have 10,000, our divisor is, it keeps increasing by the thousands, right? Generally. So you would want to have a value that can actually, you want to have like a divisor that actually works, right? So to be able to get that divisor value, divider rather, we'll just call it 1. Then to be able to get this value, we say, okay, while x, that's while the value that we have right now is greater or equal to our divider times 10. Why is it times 10? Because you know that on a normal day, so let's say you have 8, for instance. 8 is actually supposed to be in the tens, right? The same thing with 12, and you get what I'm saying. Like it has to be greater than or equal to the 10 to be able to, like, get into this while loop. I don't know if I'm doing a good job of explaining this, but yeah. So basically, what we're going to do is, if it's greater than or equal to, if it's greater than or while it's greater than or equal to the divider times 10, what we're going to do is that we're actually going to do divider times equals 10. We'll just keep increasing the value by 10. We'll just keep multiplying it by 10 until we get to a particular value. So for instance, for 121, it's going to be 121, okay, or 121 at this point is greater than the divider times 10, which is 10 basically, right? It's greater than 10. So because it's greater than 10, we'll just increase the divider by, like, we just say, okay, whatever it is in the divider times 10. So now the divider is 10. We come back again, and 121 is still greater than the divider times that. Okay, 121 at this point is now the divider at this point is now 10, right? Now 10 times 10 is 100, but 121 is still greater than the divider times 10. Does that make sense? So because that is the case, we have to increase the value of the divider one more time. In this case, it's now 10 times 10, which is 100, right? Which is great. Now the divider is 100. Now when next time we come back, we have 121. Is 121 greater than the divider times 10? You remember it's 100 times 10 at this point is 1000. So it isn't. So it jumps out of the loop, and we have the value of our divider at this point to be 100. You get? Now when we get back to this, now that it's out, we just check for the value of x, because remember, the whole point of this is just so that we can be able to get the leftmost value and the rightmost value. So while we still have x, we keep doing that, but when we finish everything and we don't have any more values, we want to return true. Okay, return statement, very important. Okay, we want to return true. Great. Now when we are here, how do we get the rightmost element? If you remember, we said that to get the rightmost element, we just have to take the modules of the number. So x modules 10, whatever that is, that's going to be the value of the rightmost element. And then for the leftmost element, is already going to be x divided by whatever the divider is. at this point. So for us in this case, all right, most elements are going to be 121 divided by 10, which is going to give us 1, and then 121 divided by 100 at this point, which we're actually going to have to floor this value, because otherwise it can potentially give us like a point situation, can have a point situation. So when you floor this value, it's going to give you 1. So 1 is 1, right? So now what if we check and right is not equal to the left? In this case, we just want to return false. We don't want to go on, we just want to return false. But what if we check and it's the same, just as in this case? So what we want to do is that we want to reduce the value of x, right? Now we don't want x to be the same value anymore. We want x at this point to now be equal to 2, right? And to do that, we just get the current value of x, take the modules of the divider, and then we divide it by 10, which is like our default. And yeah, and this should give us 2. And then the value of our divider, if you remember, I said the value of the divider is going to be reducing by 100. Why? Because we always take off 2 numbers, and when you divide by 100, you see that we take off the first 2 numbers. And then when we're done with this, and delete this here, and yeah, I think we actually need to also floor this value. So let me just do that. Okay, and I'm also going to floor, just so I'm double sure that it's always giving me like, you know, now when we run this, our solution has been accepted, and then when we submit, yeah, and we're done. Our solution has been accepted as well. And so yeah, that is how you solve the palindrome question for numbers without converting to a string. I hope that was helpful. Leave a comment, leave a like if you are confused about something. I hope I did a good job explaining, but if I didn't, just you can ask on the comment section and I'll get to it. Thank you. Bye.